Now in this section, we shall learn about some important definitions on vector. Since we are going to start vector algebra, it's essential that we have clear idea and concept about some terms used quite freely in vector algebra. I think in a previous session, I have mentioned a few terms already. So I shall have a quick recap of what we have said before. If we consider, say, any vector, suppose this is a force vector, and I could call it F1, I'll just show it. Now, this force or any vector as such has got something called a line of support or line of action. Now, what is that? You can see I have drawn a white line extending both ways to infinite length and shown in actually dashed line to show this is just a line of support. The original force was this. This was the green arrow. You are aware that the length of the arrow gives the magnitude of the vector, in this case force, and the direction is given by the arrow cap. Now, if we could draw a line, it's a different thing because of distinction that extends both ways to infinity, and that contains the very arrow whose direction is given here by this green line, then the line AB would be calling, say this was a force vector, so I'll call it, say F1, let me call it F1, the force vector. And this line AB, extending both ways to infinity, this AB will be called the line of support of that vector F1, of the force F1. So if we could have, say another force, let me call this F2, lying on the same line, then I could just name it F2, and I could say that F1 and F2, these two force vectors, have the same line of support, because line of support extends to infinity on either way, and it contains the arrow which represents the given vector. Now in this regard, I also said that the line AB, when you talk about, to be very strictly speaking, there's a distinction between the word this direction and sense of a vector. Although we don't make the distinction usually in normal practice, but there is no harm if we know about these two terms. Direction of the force is the direction, or rather the line of support. That we should be writing like this, AB extending both ways. The direction of the force, strictly speaking, is the line of support. That might mean two possible senses. This can mean either a sense that is A towards B, as you can see, is either A towards B, that is one sense, and the opposite sense, of course, is from B towards A. So direction might mean the line of support that could have two possible senses, from A towards B or from B towards A. Now by these definitions of sense and direction, you understand that one single direction may have two different senses. Although in general practice, usually in writing, we don't make the distinction, and whenever you use the word sense or rather direction, it might mean the word direction or sense both. Almost all the time you say direction is from A towards B or direction is from B towards A, and in that case direction and sense have the same meaning. Now collinear vectors, the next thing I said is that the vectors which have got either the same line of support or parallel lines of support. So let me draw a few lines of support which are mutually parallel as I'm just arranging them. These are some lines of support, right? All of them, they're in white lines and they are extending to infinity either way, and they are parallel. So here I could say F1 and F2, since they are lying on the same line of support, they are collinear vectors. Let me choose another force vector here, that is F3, lying on a separate line of support, and here is F4. They may be quite apart. This doesn't really matter. So here you see, this is, I'm naming it to be F3 force vector, and it is F4. They have got maybe opposite senses, but I don't care about that. I would say F1, F2, F3, F4, they are all collinear vectors because they have either the same line of support or parallel lines of support. This about collinear vectors. Now here incidentally, I have said already, the same line of support doesn't ensure they have the same sense. So here F1 and F3, they have parallel lines of support and they have the same sense from A towards B. So they are called parallel or like vectors, while F1 and F2 or F2 and F3, they'll be called anti-parallel or unlike vectors, because although they have the same parallel lines of support, they have opposite senses. So that way, F1 and F3 are parallel vectors, F2 and F4 are parallel vectors, but F1 and F4 or F2 and F3 are anti-parallel or unlike vectors.
Hello students, you got a glimpse of our video lessons through this small lecture. We have hundreds of lectures like this one covering various topics of advanced school level and intermediate physics in our website. They are exhaustive and often accompanied by elaborate diagrams to make concepts even clearer. They are taught with passion and sometimes with a bit of fun. So, at the end of the lesson, you have a commanding grip on the subject and you are ready for the board and competitive exams. Subscribe at physicsacademyonline.com to access video lectures of highest standard on various topics of physics.